Howdy! Last few days I was busy reading the source code of Balatro, a truly inspiring roguelike deck builder game that was written in Lua. But when it comes to code quality, it's a popular opinion that Balatro isn't neatly written. I mean, we all seen that screenshots of a Balatro code containing a huge if-else blocks. And while it's mostly true, at the same time, honestly, I was flabbergasted on how well the game code is written when it comes to maths. Low-key, Balatro's code is packed with clever mathematical shortcuts. Small fractions, magic numbers, float tricks, decimal lanes, it's all in the code, and let me tell you, it's quite interesting. Furthermore, the developer has, let me pronounce this correctly, interdisciplinary understanding of mathematics and game mechanics. It means that the solo dev behind Balatro is kinda hella good at maths. We're also going to look at the source code architecture, design patterns like Flyweight, composite, command, etc., how the game manually handles Lua's garbage collector, why the save files in Balatro introduces a possible security concern, a way to simulate OP through Lua metatables, and much more, so make sure to stay along. And a quick milestone before we get into the code. We just hit 10k subscribers. So I just wanted to say thank you all for the support. You're all awesome. Okay, that said, let's start with how Balatro startup code works. Inside the files like main Lua and global Lua, we can see a bunch of flags and initialization code as well as tons of requires. And at the very first line, it also turns off JIT compiler specifically for IRM-based Mac users. Probably that's because a well-known stability issue with Lua JIT on IRM64. Of course, this way the game runs a bit slower, but since Balatro isn't that heavy, the performance hit should be negligible. And one field that caught my attention is a PS4 PlayStation glyphs. Usually, you won't see a game support both PS4 and PS5 gamepad glyphs, so you have to install mods in order to change them. But Balatro actually comes with a DualShock accurate icons. Though the fun part is that it's somewhat a compile time flag. I mean, it doesn't change at the runtime. And apparently the glyphs are only used for PS4 build of the game. On PC, it's always PS5 glyphs no matter if the DualShock is connected, which means you still have to use mods to activate them. There is also a commented out code that calls loadString function and passes through an encoded ASCII sequence. In Lua, loadString lets you pass a code as a string and then execute it straight away. If we try to decode it, we get this. Apparently, at some point, it was used to block the game from running on mobile phones, for whatever reason. And we can also see multiple set of flags and values for various platforms and operating systems. One thing though that stands out here is a save timer. Probably because console's I/O is usually slower, the save timer here is 6 times less frequent compared to PC. Balatro saves every 30 seconds on consoles. Also, the controller rumble intensity is different across consoles. Xbox gets the strongest vibration and PlayStation the weakest. I guess now you know on what platform to purchase the game for your girlfriend. Oh my god, that was so awful joke. Okay, now, in Balatro, every hand you play scores chips multiplied by mold. Essentially, higher rank cards and face cards gives more chips. And cards like Jokers can apply enhancements to grow your multiplier. And if you ever played the game, I mean, you know how it works. But I want to analyze how exactly maths of scoring is written in the code. How the effects applied, in what order, how they are calculated, etc. So basically, it has 5 sequential phases, all sharing the same chips and mult values, wrapped into a blind debuff gate with a single final multiply math operation. Now that wrapper gate in the code checks if the hand falls under the blind debuff. Let's say the Psychic, that requires the player to play at least 5 cards in a hand. If it's true, all the phases will be skipped and you get a message saying not allowed. Otherwise, the phase 1 begins. the chips and malt get set to a base value depending on the hand type. The hand type itself is determined inside getPokerHandInfo function, and with a bunch of if-else blocks it says both hand type text and the score in hand. It's important because a hand can contain multiple entries, but only the highest will be scored. We can also see that a function evaluatePokerHand is responsible for actually recognizing the hand type. It utilizes a bunch of other functions to recognize some particular hand types and then returns a table of every hand the player cards could possibly form. Notice how at the end it also fills the result with the subsequent hand types. Thus, 3 of a kind also falls under a pair of cards. It's required because some Joker effects works on pairs even when the hand type is different. And after that, the code iterates through all jokers and applies their before effects. Those are things that need to fire before an actual card scoring begins. Any blind modifiers are also applied at this phase, as well as things like first hand bonus. At the second phase, it calculates each scored card left to right. It adds base value plus enhancement and then checks if the card is lucky, glass, etc. It also adds to the multiplier if the card has, let's say, holographic edition. Notice that repeats are collected per card before the inner loop starts, which means new reps can't be added during the loop. At the third phase, the code scores each held card left to right. It's mainly used for steal cards or special joker effects that apply effects based on held cards. However, unlike the previous phase, this one uses a while loop instead of a for loop. So if a new rep gets added on the first pass, they will be processed. The fourth phase is where all the magic happens. It's used to apply each joker plus consumable, left to right. It adds things like foil joker chips, hollow joker malts, joker's own chips value, etc. And also the code here checks for any joker to joker interaction. There is no repeats at this phase, and a polychrome joker's multiplier fires the last within the iteration. That way it multiplies the biggest possible malt after everything else has already stacked. It also means that it's kinda crucial to sort the jokers properly, because polychrome works best when placed in the rightmost slot. Phase 5 calculates your deck's effect, but as far as I can tell, only the Plasma deck does anything here, which is quite interesting because Plasma deck averages chips and malt right before the final step. By the way, it was actually mathematically proven to be higher in almost every case, and I suppose it's not a coincidence that a deck like this was added to the game. And the last step in this formula is to actually calculate chips by malt. That's pretty much the order of all operations for each hand in the code. Let's take a small break by looking at the most criticized parts of Balatro code. Inside card.lua, we can find a massive if-else chain with approximately 190 else-if branches that is used mostly to set various data for abilities. And one more huge if-else chain takes nearly 1800 lines of code. This time it's inside a calculate joker function, which is used to calculate every joker's effect in the game. Funny enough, it uses a context dispatch approach, and instead of calling a separate function per joker, the same function receives a context table with Boolean flags indicating what kind of event is happening. So whether a joker will be activated or not depends on which context they care about. Genuinely, it's somewhat a reasonable and extendable design that was completely destroyed because of those huge if-else blocks. And I guess in some way we could call it a strategy pattern, but without any sort of encapsulation. So if that's a bad practice to write code this way, what is the better solution? Honestly, as long as code works and there is no technical debt, it's fine by me. But of course, you can always think of a better ways to write things. With tooltips, for example, it could be replaced with a lookup table. You can also split those into multiple files, which makes it both easy to read and edit. And the joker effects could receive a proper strategy pattern implementation. So adding a joker means creating one more file with no edits to a shared code. At least that's the first thing I can think of. Now, let's inspect another exciting part of Balatro, how card sorting code works. And this one is quite interesting, trust me. It utilizes a clever decimal length trick to make it work as intended. And I want you to look at this code. This single formula is responsible for literally all variables involved in cards comparison. It returns only one floating point number where each piece of data lives in its own decimal lane. Card rank goes in the whole number part. Face cards ranking goes in the tenths, suit goes in the hundreds, a unique card ID goes in the millionths, and the original suit, which keeps cards starting suit even if something later overrides it, goes in the 10 millionths. Notice how each layer is at least 10x smaller than the one above. It's made on purpose. Suits differ by 0.01, and the original suit has to stay well under that gap, otherwise it could corrupt the suit lane. And because of that, layers will never collide. A higher rank suit will never accidentally outweigh a lower rank. For a better understanding, let's look at an example. Say a hand contains both Queen of Hearts and the King of Hearts, and even though both of them has the same rank value, King still outweighs it in the comparison because of a higher face value. And probably one more interesting finding is that the same function has this line of code. As you can see, it sets the multiplier to exactly 1000. This way it promotes the suit field above the rank field. Obviously, it's used when the caller needs to sort or group by suit first. Balatro also has two jokers that deserves our dedicated attention code-wise. A blueprint joker that copies whatever joker is immediately to its right, and a brainstorm joker that always copies whatever joker is in the leftmost slot. The fun question is, what happens if you have blueprint right next to other blueprint, or let's say a brainstorm in the leftmost slot? How exactly the code will handle these cases? Of course, at first glance it looks like a bug or an infinite loop, but in the code there is a special def counter that prevents any unintended behavior. So every time a blueprint or brainstorm delegates to another joker, this counter increments. And if the counter ever exceeds the total number of jokers plus 1, it then returns nothing. And if you try this trick with the blueprint, they both will copy the card to the right of the rightmost blueprint. That means you can stack them, making a cool combos. Code-wise it works because it recursively calls other jokers calculate joker function. That's simple yet effective code. And for jokers like brainstorm, there is even a special don't copy yourself check in the code. It catches described example immediately and once again returns nothing. Okay, now let's take a quick look at how Balatro's random number generator works. Spoiler, the entropy is your mouse position. So obviously Balatro needs random numbers for tons of things. Will this glass card break on this turn? What malt will misprint joker give? Etc. But those random numbers must be predictable. That way, if you play the same run with the same seat, the same things should happen in the same order. Count how many times I said same. Cheers. The solution is quite simple though. Balatro uses a random number generator where each named purpose, say glass, misprint, etc., gets its own independent sequence of random numbers derived from the run seed. Thus, rolling the glass dice doesn't change next roll for the misprint or any other purpose. And as far as I can tell, it's called a per-key seeded RNG. It's a brilliant way to prevent one random event from messing up the reproducibility of all the others. By the way, funny enough, the seed generation uses your mouse position as an entropy. It uses an X and Y coordinates as well as a hover duration at the exact moment you click New Game button. I guess a mouse jitter acts as a cheap hardware entropy. At the beginning of this video, I've also mentioned that save files in Balatro introduces a minor security concern. Let's investigate why. As you probably know, other games mostly save data in a binary formats, or at least text data like JSON. For example, in Hollow Knight they use an AES encrypted binary files that contains JSON-like data. Now, Balatro saves is a completely different story. When the game gets saved, it converts the entire game state to a Lua code, compresses it, and then writes to a disk as a file. So when the game is loaded, it does the opposite. It decompresses the file and then literally runs the code inside that file to reconstruct the game state. Actually, we can reproduce this manually and then open it in any text editor. Voila! Here's how the save file of Balatro looks. Now, when I call it a security concern, I mean the contents of the save data potentially may be replaced with an arbitrary code. There is not much to worry about though, because Balatro is an offline game, and unless you will download a save data on purpose from some random website on the internet, there is nothing to worry about. And yes, of course I know that Lua is mostly used as an embedded runtime, thus it has tons of sandboxing options. However, there is nothing like that in the source code of Balatro. It's just straight up reads the code with load string function and executes whatever there is. Probably the only reason I wanted to highlight this is for other developers to take notes. We also need to discuss how event system works in the code, as it's quite important when it comes to the code architecture. A global event manager is all responsible for this. It has like 5 queue pools and 5 trigger types: run immediately, run after a certain delay, animate the value smoothly, wait for condition, and keep running until a timer expires. Those are all event types used in the code. In the main game loop, Event Manager checks all of the pending events and fires anything that's ready. Some of the events can also be marked as blocking, meaning they prevent anything else from running until they finish first, although it only blocks events in the same queue pool. This is exactly how multi-step card animations stay in sync with the game logic. It's also worth pointing out that animating a value writes directly into a table field on every tick, which means there is no separation of a value displayed on the UI and the actual field that stores it. They are pretty much the same. The Event Manager also rate limits the processing to 60 ticks per second of the real clock. So no matter if the game runs at 100 FPS or higher, certain things still get processed 60 times per second. However, it depends on what clock the event is set to. And that's another interesting detail, as there are 2 clocks in Balatro source code: real and total. The main difference is that total includes fast forward multiplier, while real clock doesn't. For instance, tooltips use a real clock, so that it always takes 0.3 real seconds for them to fade away regardless of the game speed. And things like card flip animation uses a total timer instead, thus it can be animated faster. That's pretty much how the event system works, and how Balatro manages to queue, calculate and process things just like intended. One more interesting detail I found in the source code of Balatro is how exactly it renders the current score. First of all, we can see a well-known alt-reverse comma trick, which is used to format large numbers with commas. The code is that simple. Reverse a number string, insert a comma every 3 digits, strip the leftovers and then reverse it back. The function also switches to a scientific notation for numbers larger than 100 billion. As far as I know, some players manage to reach those numbers quite often. However, once a score exceeds a maximum of what 64-bit float can hold, it then silently promotes the number to infinity, and it's displayed pretty much the same on the UI. The fun part is that this case is not handled in the code, so apparently the developer had no idea this much score is even possible. Or maybe it's vice versa, and he left it on purpose as some kind of honor badge. Anyways, looks cool. Now, because the game is programmed in Lua, it utilizes a garbage collector to clean up objects no longer needed. As always, the issue is that it can cause stutters. Balatro solves this by manually triggering garbage collector in a tiny sliced increments every frame. As you see, the time budget variable is set to 0.3 milliseconds, which is a maximum time GC can take per frame, in order to prevent stutters. And if somehow the memory goes above 300 MB, a so-called emergency cleanup will be triggered. It runs a full pass of GC no matter the stutters. The comments also explains that this code was borrowed from an external library written by Max Cahill in 2021. Honestly, this is the first time I see GC stutters work around like this, and I have literally zero idea how effective this approach is. For instance, Silksong also had a similar manual GC triggering, with their own thresholds and GC logic. If you want to check it out, you can watch my Silksong code review video. I leave a link in the description below. And probably the last thing I wanted to show you is a bunch of interesting code architecture decisions. The developer of Balatro made an OP-like code architecture with Lua metatables. So every game object, whether it's cards, blinds, joker tray, etc., is sort of a class. Of course, Lua doesn't have an OP out of the box, but you can achieve a similar structure with metatables, which means you will be able to inherit parent objects by chaining these tables together. The inheritance chain for most objects in the game is like object, then node, then movable, and then cards, blinds, sprites, etc. The comments also points out that the base object code has a MIT license and it was taken from a previous game of the developer called SNKRX. We can also find the use of a flyweight pattern in the code. Well, kind of. All joker, tarot, planet and voucher definitions are located in one global shared table called G.P centers. So every card object holds a reference to the definition entry rather than a zip copy. That's a flyweight, because no matter how many cards you have, they all point to the same single definition. However, when the card is created, some base values like chips gets copied, so each card can mutate its own state independently. That's why I said it's kind of a flyweight pattern, because some data gets copied and some are shared read-only. Of course, we can also find a state machine pattern in the code of Balatro, as well as composite pattern, chain of responsibility and some other patterns, but most of them cannot be considered a proper textbook implementation, so we just skip them. Anyways, that's the source code of Balatro. Yep, it's not perfect, but it's a shipped code that blew up on Steam. Which is, by the way, a great thing, because it means that you don't need to write a perfect code to make a good game. Hopefully, it'll give more confidence for beginner developers out there. With that being said, thanks for watching. I'll see you in the next video.